So this is the basic overview of our circuit. There's a transmitter and then there's a receiver. In the transmitter section, we have 3 different steps. First, we would need to have the mic and aux, which is the AC signal, and then we would need to amplify it. And then once amplified, transmit all of the information through the laser. And then on the other end, we would have a receiver, which would have 4 different steps. And it would have a solar cell, which would receive the signal from the laser, and then it would filter out all of the noise from the light and etc. And then it would amplify whatever receivement the solar cell is getting from the laser, and then it would output it through the speaker, making music, making it as a mic or whatever, all through a laser. This is our circuit that is used to power both our transmitter and receiver. Without this battery, this 9-volt battery, it would be very difficult to actually test our circuit 20 feet away from each other. And so what we have is we have 2 resistors, each 100 ohms, and they're the same because it would essentially divide this 9 volts into 4.5 and the other 4.5. And it goes through an op amp in order to have a V supply of 4.5 and a V negative supply of negative 4.5, which then could be used to power our entire circuit, while this V out being ground. And the reason why our resistors are low is because we wanted a high enough amplitude or a high enough amp in order to power our entire circuit thoroughly, because since batteries have a very low amplification compared to all of the other things that we have, it'd be really good to use a low resistor, even though it makes the battery run out of power quickly. As you can see, this is our circuit for the transmitter section. And right here, this is a small circuit for our mic. And we would have 4.5 volts powering this mic. And these 2 resistors are essentially filters. We would adjust their values in order to filter out certain frequencies. And then we would have this output, which would then go into an op amp, which would essentially make a gain. And it would gain this mic signal. And so in this scenario, we use 20 ohms as R1, and we use 8K ohms as RF, yielding a gain of 400. And then once this mic audio transmission is increased, it would then go into a summer circuit, which is summed with the aux. And then it would go through another op amp gain, and the gain is depending on what these potentiometers are in order to ensure that this mic is not overpowering the aux and vice versa. And then once everything is amplified, it would go through a bias T. And essentially what this bias T has is it has a capacitor where the AC signal is coming from, and then have an inductor where the DC current is coming from in order to power the laser. Now the capacitor and inductor ensure that there's no DC current flowing this way through the capacitor and into our AC current. And this inductor is ensuring that there's no AC signals going to our direct current, and it would all go through where it needs to go through the laser. And then the laser would then transmit to our receiver.
So this is our receiver, and this is solar cell, and we go through the capacitor and to the inverting amplifier, and then goes to full buffer and goes to speaker. So this amplifier is to use to amplify the signal, and for the how much it amplifies, we use this formula. So gain equals to RF over R1. So I use 3.8 k ohms and over 75 ohms, so the gain is about 50, and that means we make the signal 50 times than before. So that's a receiver.
Hello. That's good. Okay.